What if there exists something darker than a black hole? Not because it is denser, but because it is emptier. In the energy filament theory, the silent cavity is a cosmic bubble inside the responsive universe. A fast-spinning low-tension vortex where stable particles and long-lived structures struggle to stand. Start with the base picture. The universe is not an empty stage. It is an energy sea, and a sea can do more than ripples, it can form vortices. A silent cavity is the empty eye of such a vortex. It is not outside the boundary shell. It can form inside the universe we can interact with. Its inside is not nothing. It is the sea itself rotating so fast that the local condition becomes too loose to keep knots tied into stable particles. You can picture it like a whirlpool in the ocean. The outer water spins hard, while the center looks strangely hollow. Or like the eye of a hurricane, the walls rage, but the eye is thin. The emptiness here is not zero energy. It is low structure. The medium is present, but it won't easily crystallize into lasting matter. This is also why a silent cavity is not the same as an ordinary cosmic void. A void is mostly about low matter density. A silent cavity is an abnormal sea state. Even if you removed matter from a region, the underlying terrain could still be a mountain or a valley. The environment can be extreme, even when the inventory is empty. Now grab the gravity intuition from earlier episodes. In this picture, gravity is not a mystical pull. It is the slope from looser to tighter tension. A black hole is a deep valley because its mass tightens the sea violently. Objects fall down the slope towards the cheapest tension cost. So matter piles up, heats up, lights up, and often becomes very visible through accretions and jets. A silent cavity is the opposite extreme. It is not a valley, it is a hill. The sea is twisted looser, like a high ridge in the tension landscape. Hills don't swallow you, paths curve around them. And if matter ever drifts inside, it tends to slide outward and leak away. That creates a negative feedback. The more empty it gets, the easier it stays empty, and the looser the interior remains. A black hole is positive feedback, more in falling, deeper valleys, more in falling. This is why the blackness is different. A black hole is dark because it is too dense and hides light behind a critical region. A silent cavity is dark because there is little to glow. No stable accretion engine, no easy long-lived matter inside to heat and radiate. It can be more black in the sense that it offers fewer standard beacons for us to notice. So how could such a bubble persist without instantly being filled in by its surroundings? In this picture, rotation is the support. Fast spin can hold an eye open, the way a vortex can maintain a hollow center against pressure trying to close it. The sea is not a rigid solid, it can carry a long-lived rotating pattern that stabilizes a low-tension cavity. Mainstream frameworks rarely predict this kind of object in a natural way, partly because they do not treat the vacuum as a medium with tension states, and partly because rotation of the underlying stuff is not treated as a primary degree of freedom in the same physical sense. Here, once you accept a sea, a vortex bubble is an almost unavoidable possibility. Now the practical question: if it doesn't have an accretion disk, doesn't launch bright jets, and doesn't advertise itself with fireworks, how do you find it? You don't wait for it to shine, you watch how light detours. In this picture, a black hole behaves like a converging lens, focusing and piling paths. A silent cavity behaves like a diverging lens, pushing paths outward and leaving a different lensing residue. The kind of residue that could be misfiled as extra unseen mass if you only allow one kind of explanation. And because the sea inside is looser, the relay is more difficult. Motion and propagation can look sluggish in raw medium terms, even while local particle rhythms and clocks can be rewritten in a non-intuitive way. The punchline is simple: a black hole is the too tight extreme. A silent cavity is the too loose extreme. If the universe is a medium, both extremes should exist. Next episode we turn this into fingerprints. What patterns in lensing, dynamics, and background structure would separate a diverging silent cavity from ordinary voids and from dark matter halos? Tap follow, share it on New Physics, clear universe.